Okay, so what is the difference? Go ahead.
Function returns a value, whereas a procedure doesn't.
Yeah, fair enough. So functions return a value, procedures do not. A follow-up to that might be, when will we use each one? So do we have a rule of thumb, just like we had a rule of thumb for variables? Do we have a rule of thumb when we would use a function versus using a procedure? Go ahead. Okay, wouldn't that be a good rule of thumb for either of those? Yeah, that whenever we need to do something repeatedly, some sort of logic, we would choose either a function or a procedure, any of those, right? Kind of encapsulate that logic into a single recallable, pod, for a lack of a better phrase, so that we can go back to it whenever we need to. So when would be a rule of thumb for when we would use a function? Kind of give me, we went through a little mental checklist. If we knew we needed to do something multiple times, so we've already decided we're going to need either a function or a procedure, when would we choose functions? Go ahead.
When we needed to take in values and then spit out something that we need to utilize further.
Okay, well, so they'll both take in values, right?
Yeah.
Functions and procedures both can take parameters, but at the end of the day, it's if we need to call upon it, whether it does something internally or not, spit stuff out to the screen, whatever, if we need it to then return to us a value. So a rule of thumb might be if we're having it do mathematical calculations, or we're having it do more than just act something out on the screen. Okay, it has to, if it's actually going to give us something back that we can choose to do something with later on or not, then we're going to use a function. If it's just going to do some stuff without ever giving us any feedback directly, then it's a procedure. Okay, so homework assignment was to teach Ted how to add two fractions, right? So we're going to have to bring in 4 pieces of information. We have 2 fractions. We have a numerator 1, numerator 2. So if we kind of plan this out. So we have add fractions. Maybe that's the name of our function. So we might have parameters. num1, denom1, num2, denom2, something like that. So these would be the 4 inputs to our add fractions. So let's go down that path. Is add fractions a function or a procedure? Okay. Okay, if it's a function, what does it return? Okay, and what is answer? So if we're going to implement this as a function, it has to return one thing, right? Now, technically, we were looking at this like, well, based on what we know right now, the answer is kind of going to be 2 things, right? A numerator and a denominator, but we only know how to return one thing. So if we chose to implement this guy as a function, which is fine, okay, what kind of value could we currently return that could encapsulate both a numerator and a denominator? A string. Yeah, so we know how to kind of glue crap together into a single string, so we can go ahead and build that fraction string, spit it out, and now that could be our one response. All right, so that's what we would do if we were doing this as a function. Now, the advantage of you doing this as a function is we can get that piece of information, we can hand it off to somebody else for them to do. Let's say Ted had a buddy, Rick, and he wanted, I just was watching with the Walking Dead last night, so Rick's so in any case, so he has a buddy named Rick, and he might want to give him the result of an add fractions function. So he's going to give him that string in our current case, because that's what we know how to represent. As opposed to Ted just taking in 4 pieces of information, doing the internal calculations, and then saying out loud what the answer is. That would be implementing this as a procedure. We're not actually returning the value. We're not giving it to somebody else. Ted's just internally doing the logic and then saying the answer is 5/8 or something like that. Okay. And at that point in time, the value's been lost. We no longer have a string to store it, all this stuff. So either one is valid. Okay? There isn't a correct answer whether we should do this as a function or a procedure. We certainly should do it as one of those two because we want this to be a repeatable logic. Okay? We're going to do it as a function so we can build that string, spit it back out. Worst that happens, Ted chooses just to speak the answer, or now he also has the option to hand it off to somebody else. So we're going to take our 4 inputs here, and we're going to have to do some logic. So first thing is we need to get the common denominator. So getting the common denominator is going to require us to multiply the first denominator by the second denominator. So maybe we have something called common denom is equal to denom1 times denom2. All right, so we're just kind of writing pseudo-code-ish stuff out here. All right, and that's going to get us our common denominator. Now, we now need to update update numerator 1 and numerator 2 to take into account that new multiplication. So we'll call this new num1 is equal to num1 times denom2. New num2 is equal to num2 times denom1. So this is that cross multiplication stuff. Okay, so now presumably new num1 is bigger than it used to be, new num2 is bigger than it used to be, but relative to each other, they are the same value relative to their denominator, relative to the common denominator. So now we can get our final answer. So we'll say answer num is equal to new num1 plus new num2. And then our answer denominator is our common denominator. We could have chosen to call that answer denom if we wanted to. In fact, we can still do that just to keep it consistent. Answer denom. And then ultimately we're going to return answer num concatenated with a slash concatenated with answer denom, kind of building our fraction looking string. Make sense? All right, so that's our algorithm. This is the recipe that we had to put together to add some fractions together. So now we're going to turn this guy into an actual Alice function, and it's going to be owned by Ted, because Ted is the guy who knows how to add fractions. All right. So let's go in here. We'll select Ted from up here. Well, actually, we're selecting all map inquiries. They all have the add fractions ability. Ted is an instance of one of those. And we're going to give him a new function, because we've decided to do this as a function. The return type, we decided, is going to be a text string. We're going to be talking about arrays today. That's why I said at this point in time, we don't know how to return 2 values. All right, so right now we know how to return 1 value, so there's our text string. We're going to call this guy add fractions. And let's give ourselves some parameters. So we're going to have 4 whole number parameters. So we have num1, denom1, num2, denom2, all right, so there's our 4 parameters coming into this guy. Let me squeeze that down a little bit. All right, so we'll go back to our recipe. What does this guy say to do first? Well, here, after our parameters, it says, let's get the common denominator. So we're going to create a variable called answer denom and have that equal to our 2 denominators multiplied together. Fair enough? So let's go ahead and give ourselves a variable. This guy is going to be a whole number. We're going to call this guy answer denom. And we'll just set it to 0 for right now. Then we're going to change it to a math function. And it's going to be a couple of things multiplied by each other. And we're going to have denom1 multiplied by denom2. So there's our answer denom. So far, so good? All right, let's go back to our recipe. So again, look at the value of this, the value that we spent some time planning this. So we thought about how we're going to make the lasagna. Now we're actually following it step by step by step to actually make the lasagna. Okay, lunch is coming up soon. All right. So that's our add fractions right there. All right, so now what's next? Next, we need to give ourselves a new numerator, well, two new numerators, num1, num2. So let's go one step at a time. So we're going to create a new variable called num1, and he's going to be the updated version of num1. Because remember, I think we learned last time that Alice does not allow us to directly change our input variables. Okay? At least I'm pretty positive that's the case. Let's just try something here real quick. It does not. At least I don't think it does. Can we do num1? We cannot. Okay, good. So that is a true statement I just said. All right, so given that, we'll go ahead and create a variable, which is fine. Let me actually cover that real quick. So the idea is we could create a new variable like our recipe says. We could create a new num1 that is the updated version of num1. Or, looking at this from a generalistic programming practice perspective, we could update num1 to be equal to its updated value. So we can say num1 is equal to num1 times denom2. Because we don't need the original value of num1 anymore. We can go ahead and change it. Alice doesn't let us do it. Java would, but in this case it's not hurting anybody, and we might as well create the extra variable with a decent naming convention so we kind of know what that guy is for. He is the new numerator 1. Make sense? So that's never going to be a bad idea, and if we end up wasting a couple of lines of code creating some extra variables that help us keep our mind in the game, so be it. That's probably better for us right now. So we'll create another variable. This guy is going to also be a whole number. We're going to call this guy new num1. And we'll give him an initial just 0 so we can do some math stuff here. So we'll update that 0 to be a math formula. What's the formula going to be? It's going to be a couple of things multiplied together. The first thing is going to be num1. The second thing is going to be denom2. All right, so we look at our guy down here. New num1 is equal to num1 times denom2. Fair enough? Now let's create our new num2. Another variable. It's going to be a whole number. New num2. We'll start it off at some value. We'll update the value to a math function. It's going to be a couple of things multiplied together. This is going to be num2 times denom1. So those are those guys. All right, so now what does our recipe say to do next? It says create another variable called answer num. And this guy is going to be the sum of our two new numerators. So let's create another variable, another whole number. This is answer num. And we're going to set this guy to be some math, the addition of a couple of things. What things? New num1 plus new num2. Okay, so now we have our answer num and our answer denom. Ultimately, we're returning answer num plus answer denom. Let's go ahead and, why don't we say this? Answer is equal to that. Then return answer. Just to kind of keep with our create a variable for each individual step, build our final sandwich, return that sandwich. Okay? So we're going to create another variable called answer, and that guy is going to be a text string. And we'll then construct it through some concatenation. So here's our variable. He's going to be of type text string. We're just going to call this guy answer, and we'll start it off at hello. That's fine. All right, and this guy needs to be a couple of things concatenated together. The first thing is going to be a whole number, it's answer num, right there. And then the second thing, for right now, let's go ahead and say answer denom, even though we need to put a slash in the middle there. That'll just give us our two guys. All right, so now we have answer num concatenated with answer denom. Right now, it'll just glue those two things together, and we have no separator. So let's update our answer denom to give us a separator. So we're going to say this guy, we'll change it. I guess it didn't really benefit us to do that drop down. I thought it would give us the string stuff, but it didn't. So I put a string in there. Now it'll let us do our concatenation stuff. So it's going to be a custom text string will be the first guy, followed by our answer denom for our second guy. And the text string will be a slash. You might want to put a space slash space. Might look a little better. It doesn't really matter. All right, so now answer is going to be equal to whatever answer num is, concatenated with space slash space, concatenated with answer denom. Finally, we can go ahead and return answer. Make sense? All right, so that is our add fractions. So now let's go ahead and let's call it. So here's our main method. And why don't we go ahead and read in some values here. So I'm just going to delete everything. We'll start from scratch. All right. So we're going to read in 4 pieces of information, 4 whole numbers. So we'll get num1 we'll get num2, or let's say denom2, denom1, I'm sorry. Then we'll get num1, or num2 and denom2. So this is just us globally reading in some information from our user that we're then going to pass to TED. Denom2. All right. Now each of these guys is going to come in from our asking information from the user. So we can have the scene do this. We can have TED do this. I think they both know how to get stuff from the user. So we'll have TED do this because he's the one who's asking the user for some pieces of information. Given that, it probably would have made some sense for us to have TED remember these 4 pieces of information. But since we could just pass it right into TED's function, let's just leave it like this for right now. Not going to hurt anything. So we'll have TED get an integer from the user. Here, enter num1. We'll have him get another integer from the user. Enter denom1. Now what's interesting here is, aren't we in yeah, we're in Alice language. What I'm finding interesting is, why is it get integer from user for yeah. Alice language uses the phrase whole number. Java uses the phrase integer. We haven't said in Alice, but why does it say get integer from? Just kind of a weird quirk. I wonder why they chose to use that. It means the same thing, I guess, but So we'll get another integer, and this is enter num2, and then another integer, enter denom2. All right. Now we're going to go ahead and ask Ted to call upon his function, and we'll have him say the answer. So we'll have Ted say something, and what's he going to say? We'll just say hello for right now. Now let's expand that, and we're going to have him say custom text string followed by, let's just put a whole number in there for right now. We'll just say the answer is, all right, now that whole number is going to be Ted calling upon one of his functions. That is his add fractions function. And his add fractions function is going to take a numerator 1, a denominator 1, a numerator 2, and a denominator 2 as inputs. And he will say the answer. All right, so we're going to read in 4 pieces of information from the user. It's technically Ted asking the user for those 4 pieces of information, but we're remembering those as local variables of main method. Then we're going to pass those 4 local variables to Ted, to his add, well, specifically to his add fractions function. His add fractions function is going to do the magic, spit back the result as a text string, and we're going to say the answer is, followed by a space, followed by whatever that answer was, whatever that text string was. So let's go ahead and run this. So let's do 1/2. So we'll do 1/2 as our first fraction, and then 1/4 is our second fraction, and the answer was 6/8. Okay, Ted got it right. Fair enough. Okay, so now let's go back in here, and why don't we go ahead and set another variable. Put it right here. We're going to call this guy answer. It's going to be of type text string. And we'll start off as hello. Doesn't really matter because we're actually going to have it equal to, oh, can I not, can I not copy this guy? Very, very unfriendly. All right, so we'll call his add fractions function again up here, passing it num1, denom1, num2, denom2. All right, and then when we print out, instead of printing out add fractions, we're going to print out the answer. So we stored the answer first, and then we displayed the answer, which then allows us to potentially use that answer again after we say it. All right, so our current output's not going to be any different. So 1/2, 1/4, there's our 6/8, but now we have access to that, that variable. All right, so what we want to look at is what kind of flexibility do we have with Alice in terms of working with strings. So an interesting thing is if we're in a language like Java, which we're going to be transitioning to eventually and definitely using tons of next semester, if we have something in the format of a string, like we have here, this answer is, our answer, which is right now 6 followed by a slash followed by 8 as a string, we can do pretty much anything we want with it in Java. We can break that string apart, giving us the 6 in one bucket, the 8 in another bucket, and then we can do some stuff with those. All right, so let's see, does Alice give us any flexibility for working with strings? I do not believe it does. But before we get too judgy, let's find out. What might be interesting here, let me create a variable. I'm going to create it as a text string, and I'm going to say it's an array. And we'll start it off as just an empty array, because I don't think we just set it as the empty array for right now. I'm just going to call it parts for a second. And I'm interested, and we'll talk about arrays here in a second. I'm interested in whether or not we can take that answer and we can split it on that slash and get our 2 parts out of it. I suspect the answer is we cannot. Yeah, doesn't look like we can, at least not. There's nothing obvious there. Okay, no big deal. Bottom line is what we would like to have is we need, our goal here would be to reduce our fraction, right? The 6 and 8 have it reduced, but maybe we want the unreduced fraction and we want to be able to pass our fraction then into our, pass our fraction into a, another function. Okay, so let's go back to our add fractions here. And what we're going to do is, instead of our answer being a text string, what we're going to instead do is we're going to say, let's just get rid of this variable answer. We'll create another variable called answer. And this guy's going to be whole numbers, but in something called an array. We'll call this guy answer. And we'll have him start off as a, well, he's going to be a array with, can we not pick our whole number guys? We already have our answers there. Well, let's just try to give it a couple of values. Okay, so let's see, can we land some stuff in there? It's not going to let me change those values. This is going to get unfortunate quickly. So it looks like we can set it equal to properties of Macangwari, but we cannot set it equal to local variables here. So I don't see a convenient way to add stuff to a, well, actually let's find out here. Here's our answer. It's still not. Answer num. And then we're going to assign. Let me make sure this works first before I explain what the heck I'm doing. Answer denom. And then we're going to go ahead and change our return type. Can I still do that? Okay, I can do that there. But can I change the kind of value I'm returning? get rid of this for a second. Well, hopefully we don't have to write this function again. We might need to write this again. Find references to add fraction. That's not going to get us anything. So let's just rename this guy to add fractions 2, and then we'll create another function called add fractions. And we'll let this guy know he's going to return a whole number array. This guy's going to return something a little different. And then we're going to use almost all the same logic. Can I copy this? Okay, copy to clipboard. Drag in here. Oh, we need to give ourselves the parameters. Num1. Denom1. Num2. Denom2. Okay, and now we should be able to just have to update these links because they're linked to the num1 denom1 from the or the denom1 denom2 from the other thing. So let's steal the next line now. Copy to clipboard. Drag this guy in. Update num1 denom2. Go back to this guy. Grab the next line. Num2 denom1. This guy. Num1 plus num2. All right, and here's our attempt to create an empty array. I am interested in trying this as a blank array, but let's just not do more than we have to do right this second. Then we'll set our couple of values. This is answer num, with the one from this guy. And this is answer denom, with the one from this guy. And now we should be able to return answer, which is an array of integers. Fair enough. So now let's go back here, save this, go back to our main method, and we're going to still read in answer, except this guy's no longer a, it's going to be funny, it won't let me change that. No, of course not. All right. Let's delete this. We'll go ahead and create our answer, and this guy's going to be a whole number array called answer. And we'll just start off as the empty array for right now. All right, and we actually want him to be equal to Ted's add fractions function, which returns an array, passing it num1, denom1, num2, denom2. And then we'll have him, I guess, print out answer 0. Let's just see if we get the 6 out of that for right now, because we're only printing out the numerator, in theory. 1/2, 1/4, ruh-roh. Okay. So let's go back into add fractions. If I switch this back to a custom array with nothing in it, and then add some stuff to it, will that fly? Looks like we're doing the right thing there. It doesn't look like he likes working with those fractions. It's not the way we're using them. Let's go back to our main method, and for right now, let's just have Ted not try to say it. Let's just get our answer and see if that... Okay, so the problem is before, when we're setting those values, it looks like let's just do this for the sake of argument. Make sure it doesn't crash when we do this. Okay, that doesn't crash. But we cannot create our array out of local values from this. Seems very strange. And I assume we cannot, that's funny. So we can't create an array out of anything but our local variables, and we can't change anything but our, we can't create an array out of anything but our parameters, and we can't change anything but our local values. So we can't change our parameters, but we can only use our parameters for creating an array. No problem. So we'll teach Ted how to remember our numerator and denominator. That answer. Okay? So we're going to go in here, go to our map inquiry. We're going to add some properties. So we're going to call this guy whole number answer num. And we'll start this off at 0 for right now. We'll create another answer denom, also a whole number. We'll start off at 0 for right now. All right. Now let's go ahead and let's assign some stuff. So we're going to assign this dot answer num equal to actually what we can do is we can do this. Well, for the sake of argument right now, let's just do this. This dot answer num is equal to answer num. This dot answer denom is equal to answer denom. Then we can build our array as a custom array, passing it this dot answer num, this dot answer denom, return those values. And let's make sure this doesn't crash now. It shouldn't. All right, so he's happy. Now let's go back to our main method and make sure that we can extract those two things. So we have our, well, make sure we can show that we have those two things. So we're going to go ahead and have Ted say something. He's going to say, the numerator is, oh, made my same mistake I usually make. The numerator is, and that should show that. And then let's just do this. Let's just have them say it again. I messed up my string. So we want this guy. Well, actually, we can do them both up here. That's going to be the numerator. We'll change this one to be that one. The denominator is, all right, this should show answer 0 and answer 1. Go ahead and run this. 1/2, 1/4. There's the 6 and there's the 8. Looks like we needed to put an extra little space in here before the denominator. Well, doesn't matter, it's just superficial. We'll make this last longer. There's our 2 seconds. So there's 1/2, there's 1/4. Numerator is 6, the denominator is 8. Proving that we got both values out of the function inside of an array. Had to do a little bit of a workaround just to explain what we did in here. Inside of add fractions, to build our array, we cannot, it doesn't look like we can add values to our array after the fact. So when you're first constructing the array, you have to put the stuff into it. And for right now, we're just going to say an array is a collection of stuff. We're going to actually talk about how arrays work under the hood. But for right now, it's just a collection of stuff. So when we built this array called answer, we had to have the values we wanted to put in there ahead of time. Well, the two values that we had that we wanted to put in there ahead of time were called answer num and answer denom. Problem is that we couldn't use answer num and answer denom because those are local values of our add fractions, and for some reason Alice doesn't let us use those to put into arrays. But Alice would let us use attributes of Ted. So we had Ted remember the new numerator, we had Ted remember the new denominator, and then we built this array in terms of Ted's couple of values that he remembered, and then spit the answer back out. So for your homework, and I'll go ahead and actually start it here, we're going to add a function. And this guy is going to return a whole number array, and it's going to be called reduce fraction. And he's going to take in as a parameter a whole number array called a fraction. Now the element at bucket 0 of that fraction is the numerator. The element at bucket 1 of that fraction is the denominator. And if you look back here at main method, you see how I use those. We stored the result inside of answer from our adding our fractions, and then we had Ted say the numerator is, here's the answer at position 0. That was the numerator. The denominator is, here's our answer at position 1. That's the denominator. Okay, so now we have our reduced fractions taking in a fraction in the form of a 2-element array. Have him reduce that fraction and return the reduced fraction as a 2-element array. Make sense? So 6/8 should become a 3/4. All right, I will see everybody on Wednesday.